Great, thank you so much, everyone, for being here, and thanks for the introduction, Scott. I'm Shwetab, and I'll help drive the discussion. And thanks everybody for being here. I think there are a few themes that have emerged through different conversations that we have had so far as well. I want to probably start with maybe asking our panel, and feel free to take it up, whichever one wants to. What does data infrastructure mean to you? How would you define it? Maybe I'll ask Brandon to go ahead.
Sure. Data infrastructure for me starts with data generation, and it starts in the lab with the sequencers, with the assays, with the machines that are producing those data. Because again, as you and I discussed earlier, metadata associated with data generation is extremely important, and so one needs to make sure that we're capturing everything down to the model of the particular sequencer that was used, so that we can go back and trace down the data, and there's good provenance. So data infrastructure starts from where that data is being generated, how that data is being ingested. So that infrastructure includes then hardware and software infrastructure for ingesting that data. And then data infrastructure also then pertains to, once those data are ingested, and oftentimes they're ingested locally, they are streamed to the cloud into various forms of data lakes and data warehouses. That then is begin to be part of that. And then beyond that, the ETLs that take those data, transform those data to make them machine learning ready for doing visualizations. All of that is kind of data infrastructure, and data infrastructure that needs to exist and play well with everything else we're trying to do.
Maybe I'll take off from there and ask Aaron to. I think Brandon gave us a very, very wide definition of what data infrastructure looks like. In your view, how has that changed over the last few years, right? You have been looking at such infrastructure across different organizations, small and large, over time. How do you think it has evolved? How are the requirements evolved? Are the challenges today any different, or are they very similar to what used to be there earlier?
Sure. So, I mean, I think everything Brand said was spot on. And, the topic of this panel is setting up that infrastructure. I've had a number of opportunities now with both small and large companies to initiate a new function in data science and computational biology, where the data may be coming off of the machines, it may be coming from a CRO. And the team is very small, and the team is used to dropping files on a SharePoint or in Box, or in some kind of unstructured thing. And so it would be great to already be in a situation where the data from the machine is already going on the cloud, and that's where you're starting from. Very often I think groups, particularly small groups, are starting with, there isn't really an IT enterprise application group, that some of the data transfer, data aspect issues have not been very well thought out yet. And how do you get from that, over that hurdle of, well, we've generated some data, and in fact, as a small startup, we really need to get everything we can out of that data. The clock is ticking. We need to show our partners and our investors that we're doing something interesting. We don't really have time to build an entirely new enterprise architecture. Not that there aren't a wealth of new technology stacks that are out there, between the AWS stack and the Google Cloud stack and the Azure Cloud stack. And each of these offers a ton of tools for a strong engineering team to put together something cohesive, that can build a infrastructure platform for a company. But often there's not time, appetite, budget, you name it for those things. So I think especially for, you know, again, either small startup companies or larger companies that are, again, kind of for the first time moving into the field of omics, and for the first time realizing that, oh, right, I'm not just going to drop you know, a few gigabytes of FASTQ and BAM files into a box folder and then hope to be able to do something, you know, nothing against box, but you know, I think that is really where the challenge is, and where the rubber meets the road. And I think the sorts of teams that, you know, those initial core teams have to be very agile, not only in the capital A software development agile sense, but really agile in the sense of you know, through agility of saying, all right, well, you know, whatever we do have, let's try to make this work with incremental steps towards getting to you know, a more sort of, you know, larger infrastructure, production infrastructure.
So, I mean, I think for a lot of initial teams, and you know, as you said, starting up teams that we work with, often, you know, it's very complex, very well designed, but very complex box structures and you know, SharePoint structures, very involved ways to capture metadata, you know, very clearly thought out, but very hard to implement. You know, of course, if you're doing it on ShareChat, on SharePoint and Box. But Emma, maybe you know, J&J being J&J does not start from Box, and you start.
We use Box as well and SharePoint.
Okay, well,
in a variety of situations.
Then maybe we have the same problems. but what's your starting point?
Yeah, and J&J, as in any big organization, different groups are at different parts of the journey, I would say, and particularly with different partners as well. But absolutely agree with what Brandon and Aaron have said. I mean, I suppose if anything's changed in the last few years, it's really the breadth and scale and variety of data that's coming in. It's interesting. I was at a conference, I don't know, a few years ago talking about big data, and they were saying, well, you know, I've been talking about big data for most of my career, but it meant something different 20 years ago in terms of it's data that we don't have the scope to handle just yet is typically what people mean by big data. But it's really placed a lot of emphasis, I'd say, on that harmonization aspect. You know, Brandon mentioned it starts from the data generation, and all data was generated for some purpose, but that purpose is usually not the same thing that we necessarily want to do with it at this point. And the same is probably true with infrastructure as well, right? We set it up with something in mind, and we have to keep building onto it and seeing what else we can do and how we can integrate other data sets and, you know, work with external partners and things like that. So it, as Aaron was saying, it really does require that iterative mentality in terms of thinking how to build onto a solid framework, like what Brandon was describing.
That's actually a good segue to talk about, I think, you know, something that Brandon and I discussed a little earlier, which was about, you know, FAIR principles and metadata, right? And something that you refer to, Emma, that it could be hard enough to figure out a consistent way to look at metadata, store it, you know, harmonize it, so to say. Brandon, in your role as you know, as a chief AI scientist, how do you handle that problem? What kind of challenges do you face, and how do you think about metadata? And I'm sure there are many challenges you face, but you know, just where do you start?
Well, I think both to Aaron and Emma's points, things evolve, right? What you said, what you start doing is not always where you want to end up. So you end up with a lot of data that is disconnected from that metadata. When I described the data infrastructure, I certainly described what I would consider the ideal data infrastructure, where you have kind of all of those pieces, but we're constantly dealing with data that was definitely not collected for purpose, right? As we talked, you know, the ideal data for me is fair and fit for purpose. That rarely happens, right? And generally, fair and fit for purpose also requires a lot of time, a lot of energy, especially when it involves human data. And so generally what we have is our data that have either been collected in our lab for different purposes, or were collected with some purpose but unknown. And so they attempted to capture those data. So we spend a fair amount of time and are certainly growing a larger team around looking at the data we do have. So it's easier to say, well, as we begin to generate data, let's make sure we're capturing the metadata that's needed. But we also have teams that are having to go back and look at data that's been sitting on the file system or that was generated previously, and try and come back to, can we surface those assay conditions, or do we have some understanding of the assay conditions? Do we have some understanding of why those were collected, what the patients, we talked about, for example, whole exome sequencing of blood. How was the blood prepared? Why was it collected? Was it whole blood? Was it Buffy coat? Was it, what are those, were the patients fasted when eating? And so there's a lot of time we spend developing that. And for me, putting my AI hat on, as I described, the people talk about bias in terms of machine learning models. You can always use a model in the wrong way and therefore create bias, right? Bias comes out of taking a model and using it inappropriately. And so one of the things that you need to be able to do is take the machine learning models that you're generating and make sure that they're capturing enough of the metadata such that they're describing the data that were used in the training set, why those data were used, and what were the underlying assumption, what are the distributions of key features and parameters that go into that, because the user of that model needs to be able to easily get that information so that scientist knows whether or not it's an appropriate model to apply in a particular situation. And beyond that, sometimes you should also have those pointers from that model to the training set, and then from those training set, you should also then be able to go back to the raw data through the ETL pipelines, and to really be able to look at provenance and be able to audit these models. That also helps as you're versioning models and adding more data, and you're looking at prediction drift and things of this nature. So again, I think as we described, I really love Andrew Ng's approach of being, yes, Valo is a machine learning driven company, we really focus more on making sure that the data are as well preserved, as curated, as cleaned as possible, because that's really what's going to push our ability to make predictions, not the next fancy, the latest and greatest machine learning algorithm.
If I may, come to Aaron now. Something that I think Brandon referred to is sort of like being able to connect the whole chain from final insight when the model was applied, go all the way back to where you generated the data. And something that I think when we were speaking before this panel discussion, you referred to it's hard enough to do that the first time, but much harder to do it on an ongoing basis, right? So yeah. Have you dealt with again, I think it's hard enough to be done even the first time, but how do you do it on an ongoing basis? In your experience, what kind of approaches, what kind of incentives, what kind of infrastructure concerns have helped to be able to do that successfully?
Right. So I'm going to end up sort of doubling down on everything Brandon said about having the metadata, spending time to have the metadata be available. To the question, it's very tempting in again, particularly in a sort of new kind of startup situation, to say, all right, well, there's all this public data out there. We can get TCGA, we can get UK Biobank, we can get, you name it, the GWAS catalog, and on and on, hundreds of, if not thousands of freely available public resource data sets that each in their own way is structured and curated and analysis ready by itself. But how do you then connect them? How do you now make use of them? How do you enable that sort of multi, I'm now VP of multi-omics, whatever that is, and but that sort of cross data set, integrated understanding, which is what we're all sort of yearning for, and is clearly the opportunity that is out there. how do you make that happen? And, you know, there's this, you know, I've seen this a number of times. There's this, you know, tendency to think, okay, well, great. You know, I'm going to set up an automated weekly download. It's going to go hit this portal and this portal and this portal, and it's going to pull it all down. And, you know, and then we'll have some script that's going to go through and map identifiers. And maybe we've been smart enough to think about getting some ontologies or other controlled vocabularies in-house to try to help manage that. And then the team does that once, you know, or they do it the first time, driven by whatever that first use case is, right? And it's not 50 different data sets, it's 2 data sets and one particular type of join to answer one question. And they do that, and it's relatively simple, and it's relatively straightforward. And yes, there's some border cases, and there's a couple rows that drop out, but overall the question gets answered. And then there's the second time, and the third time, and the fifth time, and you know, how do you kind of encapsulate that process and allow it to scale so that you can do that, you know, not just once, but hundreds, if not thousands of times, and have it be, you know, reproducible. We always want it to be reproducible. Yep. Can I go back to what happened on January 1st, you know, 1999, as, you know, as the data sets and as that integration happened then, and say, all right, and now today, if I do that same process with those same sources, you know, that have now all updated, without having to manually go back and recreate all of those various mappings. I think that is one of the biggest challenges that remains out there. You know, the old joke about bioinformatics is, you know, 90% work of just mapping identifiers continues to be, unfortunately, be the real truth. And you know, the various ontologies and controlled vocabularies, which the bioinformatics field embraced very early on, you know, continue to be helpful, but not the magic wand that we need. So again, so what I encourage, you know, and the sorts of, you know, both what I always say, it's a combination of tooling. You need tooling, you need process, and you need people. And all 3 of those things have to be working together. You can't expect the tool to do everything for you, because it's not. You can't expect, just because you downloaded all the data and it's all sitting in the same bucket, that means that it's ready to, you know, to answer everyone's questions.
And I think, you know, again, something like this can be, you know, super complex to do. I mean, in our own work, you know, on Poly, when we continue to add about 700,000 data sets, and even though we are a very controlled team and we have to do it, it's you know, incredibly hard to keep doing it sustainably all the time. If I may ask, like, you know, there are so many different groups within J&J that you work with. You also look at external partnerships, and you probably look at, you know, many data sources like the ones that Aaron referred to. They're often from different vendors. They're often different kinds. You know, I know we talked about, you know, EHR data and combining that with the omic data, and what kind of challenges there are with respect to that. How do you see you know, being able to manage metadata effectively across different kinds of data, as well as different groups, let's say within same organization, and what in your experience has been effective?
Yeah, I think there's the technical challenges, of which there are many, and there's also the cultural challenges, particularly in organizations like J&J. You know, Brandon highlighted how important, and I just like Aaron, I want to double down on everything Brandon said, but I mean, you highlighted how important data provenance is and things like that. It's important that people understand the value of these things as well. Otherwise, you won't get them to capture the metadata, either going forward or trying to go back and make sure you have it to include in your analyses. So you have to make sure you have that culture of valuing the data, valuing the metadata, understanding why you have that. And I think, you know, the place where a lot of groups have come from is more siloed than that, right? You have groups who generated their data for a particular purpose. They know everything there is to know about an experiment, but that's not necessarily captured and shared with the group. And at that point, the value resides in the data and that group. Whereas once you have a culture of that more sharing, I guess, and the culture where the value is in the, you know, entirety of the data as opposed to specific data sets, it really does make a shift in what you can do, and where the emphasis is placed. I think for us, when you have that sort of heterogeneity within an organization, there's always a tension between how can we standardize the processes and how can we set up things that make it easier for people to capture the same information so that we can compare things across data sets, as well as balancing that against some level of customization, because for different disease areas, people are interested in different things. They may be using different technologies. And so there's always going to be some tension there, particularly when you have different people involved, I guess, in different parts of the process, either in terms of annotating data sets or in terms of using them at different stages. So I think that comes up a lot within J&J, both within certain data technologies, for example, single cell, right? Are we looking to generate sort of standard data sets which are easily comparable? Are we looking, does that make sense if you're building a large disease atlas versus if you are studying, very specific experiments and what do you want to do with it? And by the same token, it comes up in terms of metadata as well. So,
if I may ask a follow up on that, are some of these concerns separated between teams? For example, who as an organization, how does J&J think about who has to maintain the data, who has to maintain the common vocabulary, who comes up with those standards? Again, in our work as well, what we have seen is that again, at smaller organizations, it's probably harder to define these separate roles. But does J&J have these different roles, and if so, how do you think about that?
Yeah, well, J&J, of course, is made up of different sectors and handled in different ways. But within Janssen R&D, for example, we have a chief data science officer, Najat Khan, who has made a huge push over the past few years to really centralize a lot of things related to data. So putting those processes in place, putting in place a data management team, which is working across all of our therapeutic areas to really put that emphasis where it belongs and to make those cultural changes in terms of having a more coordinated effort, both in terms of our internal activities and how we work with external partners, because it can be very difficult to start up new partnerships without fully understanding the landscape of what you're already doing with other partners in the space. And so having that central group really makes a big difference in pushing things forward.
I have a related question, I think, and Brandon and Aaron, feel free, either of you could answer that. For organizations which are smaller, there's often a question of build versus buy, where you're looking for let's say certain pieces of infrastructure or software that could enable what you do, versus building it internally all by yourself. Like how do you guys as leaders in early stage organizations and now bigger organizations, how do you think about that choice? What do you really want to keep in house? What do you want to get from external folks?
Go ahead, Aaron. I've gone first. I've gone first on a couple of questions.
Just to switch it up. Yeah. So I will be honest. I really do lean towards buy for that initial solution. And if I can also kind of mix this in with the question that's in the Q&A about, okay, great, we want to capture metadata. We want to be able to do that right out of the gate, but we also want to be nimble and agile, and we don't want our experimentalists to have to spend a lot of time. So it means whatever tools we are buying, if there's a build versus buy proposition, and we're leaning towards buy because we just need something to get started, then let's make sure that as we make those choices about the vendor space, that we are choosing an ELN that has an interface for drop-down menus, that has a backend of that has some controlled vocabulary as its backend, and not free text, just as one sort of example. And so, tool process people, part of it is educating the scientists. Like, yes, I know that okay, your cell line that you're using isn't in the controlled vocabulary. It's going to take an extra bit of communication to get that cell line name into the controlled vocabulary, so it's in our central database, that you can now use it in your ELN entry. You're right, that's a little bit of extra process, but it's going to pay off, as opposed to just having it be a free-for-all free text field that, so it is about build versus buy, but even in the buy category, it's about being very selective about if I were to build this myself to get to the sorts of goals that we're looking for, here are the things that are going to be most important. And where is that tool now extensible? What can I, if this tool solves these sets of problems, are there some other problems that if I now do have some internal capability that I can develop against those problems?
Yep, I think
if you want to add to that.
I concur with Aaron. Small organizations should focus on their secret sauce. Identify the thing that you as a group are uniquely qualified to improve and really value add to. Everything else, yes, you might have great ideas for doing those other things, and at some point you might get there, right? But in the meantime, there's a lot of value to making sure the pipes are all connected with these buys, with these vendors coming in. And with Aaron, one of the things that I would also say is look for the companies, look for those vendors that have those properties that you want and that you would think are essential. But also it's really nice to work with vendors and especially in this space, being relatively young from a technology perspective, that there are a lot of vendors that we are working with that have the kind of the better tools, but they're the younger companies. And so having a deeper relationship with those companies, looking at and potentially influencing their roadmaps and building things together, right? Because at the end of the day, I would much prefer to work with a younger company and influence their roadmap, and instead of having to then hire people to replace that solution. So again, I would say look for those younger, hungry companies and that are willing to open up their roadmap and help you, consult with you on their roadmap, so that you're making sure that you're getting what you need. They're getting feedback from us, and kind of all boats float at that point.
Great. So I am now being prompted to move to Q&A from the audience. Brandon, there's one more question for you. Why don't you take that one? Right.
So given metadata is often missed, ignored, captured well, what do you think of the value and the state of the art of imputation method in models? I think we are at the beginning of building those imputation models, those what I would call meta learning models for filling in metadata. So, and inferring metadata was the state. I think there's a lot of work that still needs to be done there. I think in terms of free text metadata and those types of data sets, I think the attention functions and the kind of BERT type models that we were seeing a little bit earlier at PolyBERT, really help to fill in some of that. So I would say they are getting better. They aren't perfect. And so what one should also do is focus on algorithms that maybe are a little less sensitive to some of those missing metadata fields. If we think about things in terms of missing metadata, such as I can't think of anything right now. I'm thinking more preclinical work, but in terms of metadata, it's really hard to, I think, impute, for example, medical history. If say you have a genome and you're trying to impute medical history, I think there are ways to do that. That's one of the things we are focusing on at Valo, is designing techniques for merging real world data with omic data, with kind of deep phenotypic data. But there, I think we're just starting to kind of crack that nut. But at the same time, you still need enough of a join key in both data sets to really be able to do that. But I would say not quite there. I think over the next 5 years, we're going to see big movements there, and especially within Valo and the industry as a whole. I have the next question for Emma. The question is that
J&J, and it has really many different groups and different stages. How do you share lessons and understanding of how to build, maintain, and use data infrastructure across the organization? Are there benefits, of scale for an organization like J&J?
Yeah, absolutely. I think one of the things we often say about J&J, the best thing about J&J is its size, and the worst thing about J&J is its size as well. So there's pros and cons, as with anything. So there are a number of very active data science communities, and I think that is one way that learnings are shared. And I think everybody recognizes the value of sharing those learnings, because so much of what we do is transferable to other problems throughout the organization. There's also a pretty active movement among different groups, which helps to share learnings. So that's something we always encourage in terms of thinking about career development, is to look around other parts of the organization and see where you can contribute, because and that way everybody learns more and has the chance to bring some of what we're doing in one area to the other spaces in J&J. So definitely something we encourage. I think it's taken on certainly new importance with greater coordination among the different groups, and even J&J wide, there is an enterprise data science council where you have leaders from each of the different groups across the organization, and one of their most important things they discuss is talent development, in terms of thinking about how to bring those learnings from one part of the organization to another.
I'll just add, not that Roivant is as large as J&J, but there is also, I think, a growing appreciation for, rather than there being one monolithic, centralized, data infrastructure group where all things in every department go through the same funnel, that there's more of a sort of, whether you call it hub and spoke or more kind of independence, that yes, there's a community of sharing and learning, but in fact this arm of the org could be on AWS and this other side could be on Google Cloud, and they've got good reasons and they've got good product and they're generating value for the company. So don't look at that and say, oh, well, clearly they need to converge and that one of those two teams has to rewrite all of theirs. No, just leave it.
Good point. I mean, data infrastructure is so complex that it could be incredibly hard, as we know at Elucidator, to merge all the different parts, and you're better off having microservices and specific use cases rather than having one monolithic unit that does everything. That seldom works. Aaron, the next question is for you, which is, what are the specific ETL plus curation challenges that are different between data generated in-house versus externally at CROs?
Yeah, and I typed a quick answer to this earlier. I mean, really, and again, it depends. If you're a big pharma working with a CRO, you can pretty much get the CRO to do whatever you need them to do. You have the the financial and political power to do that, particularly if it's a CRO that you're going to have a kind of long-term relationship with. For smaller startups, though, it can be very, very hard, right? You're trying to get, again, startups are trying to very acutely get that critical piece of information, that critical bit of data that's going to get them to the next step, that's going to prove that next value statement. And if they could do it in-house, they would, but they're using a CRO because that's more effective and efficient. But in some ways, you're still at the mercy then of, okay, this is what you're going to get. You're going to get a PDF report of pre-generated figures, and maybe you'll have access to an Excel sheet that also has the that same information, but you're very often not going to get the raw data, or if you do get the raw data, it's not very well curated, not very well annotated, as for all sorts of things Brandon was mentioning about all the kind of the sort of batch level things that you might actually care about. Which plate were these were these samples on versus some other samples? So you're a little bit at the mercy of having the data in a way that is well structured, having the extent of the metadata that you might want, and even, I mean, I've seen, you know, particularly for you know, CROs that are doing screening, you may not get, you know, you may just get the, you know, the top hits off of the screen and no information about the molecules that were in, you know, standard deviations 3 or 4, only 10 and above. So so there's lots of different ways that working with the CRO, you're getting a reduced representation of your overall experimental data.
I would just add to what Aaron said, and it just helps to have a strong lead scientist, lead biologist. In my experience, the only way we were able to get the metadata we needed from CROs was to have our head of biology go to the site and literally sit on the individuals running the assays, running the experiments. So it does help to have a very strong scientific lead. But to Aaron's point, yeah, it only goes so far, especially if you're a smaller company.
I think Brandon's organization got very lucky with a head of biology who really cared about metadata as well. But we hope that other organizations get them as well. With that, I think we're done. We're over time. I think a few minutes over time. Thank you so much, everyone, for participating and bringing your thoughts forward. Thanks, Aaron, Emma, Brandon. Thanks for your time.
Having us.
And I hope everybody enjoyed this. Thank you. Thank you so much.
Thanks a lot.
Take care.
Thank you.